Have you ever really stopped to wonder how your devices actually talk to each other? I mean, we send emails, stream movies, join video calls, all without a second thought. But underneath all of that, every single one of those connections has to make a fundamental choice. So let's dive in and figure out what that choice really is.
I mean, think about it right now. Your computer is talking to your network. But how does the data from your screen get to your router and then zoom out to the internet without just getting lost in a huge sea of other signals? Well, the answer lies in one of two very, very different ways of communicating.
And it all boils down to this really simple analogy. Is the connection like a private, dedicated line, like a secret telephone between just two people? Or is it more like a public square, this big, noisy room where everyone is shouting at once, just trying to be heard?
Now, this critical decision, it's not just a nice little analogy, it's a core concept in computer networking. It all happens at what's called the data link layer. This is deep in the weeds where the real rules of the road are set. So let's explore that first path, the simple, elegant, private line.
Okay, so this is what we call a point-to-point network. And just like the name says, it's all about connecting two and only 2 points directly.
This analogy of a private telephone line, it is the perfect way to think about it. Seriously, imagine no switchboard, no crossed wires, and absolutely no one else listening in. It is a completely dedicated link just for you and your friend.
And in technical terms, that's exactly what a point-to-point network is. A great example is your old home DSL connection, talking directly to your internet provider's equipment. Or maybe a big company leasing a dedicated T1 line between two of its offices. It's a direct, exclusive connection. Period.
The whole process is just beautifully simple. When device A sends a message, there is only one place it can possibly go. Device B. There is zero confusion, no ambiguity. It is the most straightforward way imaginable for two devices to communicate. And because of this simplicity, a whole host of really complex networking problems just vanish. They're gone. You don't need a special address because, hey, if you receive a message, you already know who sent it. And you don't really have to worry about whose turn it is to talk because it's just the two of you. So what this means is that instead of worrying about all that addressing and chaos, point-to-point networks get to focus on what really matters: reliable delivery. Making sure data gets across without errors and at just the right speed. That's the job of protocols like PPP. So, okay, that's the quiet, orderly private line. Now, let's step into the loud, chaotic public square.
All right, welcome to the world of broadcast networks. This is where most of us live our digital lives, especially on Wi-Fi. And let me tell you, it is a completely different beast.
Think of a broadcast network like a huge conference room. If one person talks, everyone hears them. Simple enough. But what happens if everyone tries to talk at once? It's just noise, right? It's chaos. Nobody hears anything. That is the fundamental challenge we have to solve here. This is exactly what's happening on your Wi-Fi network right this second. Your laptop, your phone, your smart TV, they're all sharing the exact same radio frequencies. It's one big shared medium. And it was the same for old-school Ethernet that used a clunky device called a hub. So this begs a really important question. If you shout a message into that crowded room, how in the world do you make sure only the person you want to talk to actually listens and responds? You can't just yell, "Hey, you," right? You need a name. And in the world of networking, that name is the MAC address. Think of it like a unique permanent name tag that's literally burned into every single network-capable device on the planet. So when a computer sends out a message, it puts the specific MAC address of the destination right on it. Every device hears the message, sure, but only the one whose name tag matches will actually pay attention and process it. Pretty smart. Okay, so solving the naming problem is one thing, but what about everyone talking at once? This brings us to a really important concept called a collision domain. It's basically the area of potential chaos, all the devices that could possibly talk over each other. On a Wi-Fi network, that's pretty much everyone in range. So how do we manage all this? Well, with a set of politeness rules. For the old wired Ethernet, it was called CSMA/CD. It's kind of like a very disciplined conversation. First, you listen to see if anyone else is talking. If it's quiet, you start to speak. But, and this is key, you keep listening. And if you hear someone else start talking over you, that's a collision. You both immediately stop, wait a totally random amount of time, and then try the whole thing all over again. It's a really clever system for bringing some order to all that potential chaos.
So we've got these two completely different worlds, the simple private line on one hand and the complex public square on the other. How do our modern networks manage to reconcile these two ideas to give us the speed and reliability we all expect?
All right, let's just break it down side by side. With the private line of point-to-point, the main challenge is just reliability, and you don't need addressing at all. But in the public square of a broadcast network, the big problem is controlling who gets to talk and when, which makes addressing with those MAC addresses absolutely critical.
Now, for our wired networks, the hero of this whole story is a device you probably have in your home or office right now, the Ethernet switch. This little box completely changed the game.
See, here's the magic. A switch is not like an old hub that just blindly shouts everything to everyone. A switch is smart. It actually learns the MAC address of every single device plugged into it. So when your computer wants to send a message to your printer, the switch creates a temporary, private, point-to-point link just between those two devices for that one conversation.
What the switch does is frankly genius. It takes a chaotic broadcast network and it masterfully breaks it down into a whole series of clean, private connections. In effect, it gives every single device its own private line, which eliminates collisions and maximizes speed. It's literally the best of both worlds. So, the next time you're on a crowded Wi-Fi network, remember, you're living in that public square, relying on all these complex rules just to be heard. But when you plug an Ethernet cable into a switch, you're getting your own private line. It really makes you wonder, doesn't it?